So for this example, we're going to be writing equations and inequalities in standard form. And standard form takes on the form ax plus by is equal to c. If it's an equation, it's equal to c. If it's an inequality, it will either be less than or equal to or greater than or equal to. But the idea is that the values with the variables, the coefficients and the variables, are on one side of the equal sign or on one side of the inequality, and the constant c is on the other side. So if we take a look at letter A here, we have y is equal to negative 5x plus 7. So we're just going to apply some simple algebra. If I go ahead and add 5x to either side, the negative 5x and the positive 5x, they wind up canceling each other. So I'm left with 5x plus y. That's going to be equal to 7. And as you can see, we have our variable terms and our coefficients on one side of the equal sign and our constant on the other. So 5 can be interpreted as a in our ax plus by is equal to c. 1 would be interpreted as b, and 7 would be interpreted as c. We do the same thing for letter B here. We have y is equal to 9/4 x plus 2. Again, using some simple algebra, if I subtract 9/4 x from either side, I wind up with negative 9/4 x plus y. That's going to be equal to 2. So here, a is interpreted as negative 9/4, b is interpreted as 1, and c is interpreted as 2. Now, often we don't like to have the leading coefficient a as negative. So in order to get rid of that negative, we will factor out the negative. We simply do that by multiplying the entire equation by negative 1 and then distribute that negative 1. And what that does is it changes all the signs. So our negative 9/4 x becomes 9/4 x. Our y here becomes negative y. And our 2 becomes negative 2. It doesn't change the solution of x and y. It just shows this in a different form. So here a is interpreted as 9/4, b is interpreted as negative 1, and c is interpreted as negative 2. Of course, 9/4, that's 2 1/4, so this could also be written as a decimal. It could be written as 2.25x minus y. That's equal to negative 2. That's another way. And again, it doesn't change the solution for x and y. It's just another form that we can write it in. As the chapter progresses, we will encounter different forms of writing an equation. And some forms are easier to work with than others. So we have to be flexible in our approach. Another way of being able to write this is where a, b, and c are all whole numbers. So we can do that by getting rid of the fraction here. So I'm going to multiply this entire equation by the denominator 4 here. And just like we did with negative 1, we're going to distribute this. So 4 times 9/4, that's 36/4, or in other words, the 4's will cancel. And I'm left with 9x. I distribute the 4 here. This becomes negative 4y. And it's going to be equal to, and I distribute the 4 over to the negative 2. This becomes negative 8. So a is interpreted as 9, b is interpreted as negative 4, and c is interpreted as negative 8. So we can see the different ways of writing the same equation where one expression may be easier to interpret than another. But again, we have to be flexible. And again, it doesn't change the results of x and y. It's just another way of being able to write the equation. Let's take a look at c. We have y is less than or equal to negative 18x plus 1/3. So if I add 18x to either side, I'm left with 18x plus y. That's less than or equal to 1/3. Of course, we could write this 1/3 as a decimal. That would be 18x plus y. That's less than or equal to 0.3, and that 3 is repeating. So you could see how it may be easier to add and subtract a 1/3 than it is a repeating decimal such as 0.3. But again, we could also write this where all the values are whole numbers by just going ahead and multiplying everything by the denominator here, 3. So then 3 times 18, that's 54x. 3 times y plus 3y. And that's less than or equal to 3 times 1/3, that would be 1. So here A would be interpreted as 54, B would be interpreted as 3, and of course C would be interpreted as 1. And once again, it doesn't change the solutions for x and y, it's just another way of writing the same inequality here. D, the same approach. We wind up subtracting out 2/5 x. We're left with negative 2/5 x plus y. That's going to be greater than or equal to 8. Again, if we don't want to have our leading coefficient as negative, we can go ahead and multiply the entire inequality by -1. Now that's going to change all the signs, including the inequality sign. -1 times -2/5, that's positive 2/5 x. -1 times y, that's negative y. The inequality sign flips, it goes the other direction. -1 times 8 is -8. So we went from -2/5 x plus y is greater than or equal to 8 to 2/5 x minus y is less than or equal to -8. Again, it doesn't change the solution of x and y, it's just another way of writing the inequality. Again, we can write this where we don't have a fraction, we just want whole numbers. So we can multiply this by the denominator 5 and then distribute. 5 times 2/5, the 5s will cancel, that becomes 2x minus 5y. That's less than or equal to -40. A can be interpreted as 2, B can be interpreted as -5, and C can be interpreted as -40. And again, certain ways of writing the expression may be easier to interpret than others, but we certainly have to be flexible. But there you go.